So that's ecological collapse. The next is a rather interesting but rarely spoken about topic called protein pollution or nitrogen pollution. It's nitrogen and phosphorus actually, but nitrogen is the big one. Because we've created so much nitrogen fertilizer and put it on the crops, what happens is that that system is a leaky system. So it gets into the groundwater, gets into the waterways, etc. But what happens is most of the crops. I think I might have the graphic later, but if the IPCC did some really interesting work on this just a couple of years ago, and they discovered that if we look at the produce from crops, from the world's crops, if just less than a quarter of the produce by dry weight goes to humans, just more than a half goes to animals, and the rest is biofuel and cotton and so on. So what happens is that the crop produce, that half that's fed to animals, it's concentrated. And most of animal production these days is in feedlots, and we concentrate it. That's the whole idea. So this nitrogen pollution, this nitrogen which builds protein in those animals, nitrogen equals protein to a first level estimate. So this nitrogen equals protein equals fattened chook, for example. They are very wasteful. In other words, most of the nitrogen is put out in their waste. And so we have these big lagoons with their waste, and we don't treat it like we treat the effluent, like we treat the sewerage from cities, from humans. We just put it into ponds. And the next time it rains, or it gets into the groundwater, gets into the waterways, and it pollutes and it kills off these waterways. It's considered, nitrogen pollution is considered the greatest coastal water and air pollutant, the greatest. It's been most studied in Europe, but Mississippi River is a classic. It pollutes the Gulf of Mexico, and now we have around the world 300 to 400 permanent dead zones. The Gulf of Mexico is a standout for that, but so much extra nitrogen in the system. What happens that it's really interesting. The nitrogen, all these nutrients come out, and the algae, they love nitrogen, they love phosphorus, and they just go nuts. So we have this algal bloom where they just go crazy. Now, what happens is that while they're doing that, they produce oxygen like a plant and eat carbon dioxide. And as soon as they've eaten up all the nitrogen in the system, they die. And then they settle out. And as they're doing that, they strip the water of the oxygen. So you end up with deoxygenated water. And this flows out into the stream. It kills the streams and the rivers and eventually the oceans. And now even the open oceans are being depleted. We'll see that in a minute. So meat production is the leading cause of nitrogen pollution in the USA. And there's 300 to 400 permanent ocean dead zones from nitrogen pollution. In Europe, they've studied it most. They've seen that to get the nitrogen to a controllable level, they need to halve nitrogen pollution or suffer toxic tides, lifeless rivers and dead oceans. And how do we do that? I don't have it there. But the way to do that is to halve the meat production. I might have it in a later slide. There's also air pollution comes from nitrogen, from CAFOs. Ammonia, PM2.5 dust, nitrous oxide, and volatile organic compounds. Downwind from these production facilities, it's not fun. All sorts of respiratory diseases, etc. And US animal agriculture is responsible for 80% of air pollution deaths due to food production. So 4/5 of all deaths according from air pollution come from animal production. Here's a map of the ocean dead zones. The red dots are the permanent ocean dead zones. The blue now is the open ocean. It's going hypoxic. Hypoxic means that it's losing oxygen. So we can see that even the open oceans now are depleted of oxygen. And in the past, oxygen depletion in the oceans has been linked with mass extinctions. So we are playing with fire. So what happens? This nitrogen that comes from the fertilizer that feeds the plant, that feeds the animal, that feeds people, most of that nitrogen is wasted. If we eat chicken, 80% of the nitrogen that's fed to the crop is wasted. If we eat beef, 96% of that nitrogen is wasted. So, for example, chicken is the most efficient of those meats. So it's as though this will be interesting to those who are worried about food waste. So it's as though if we eat chicken, it's like putting 5 bowls of pasta in front of us on the dinner table, having 5 bowls of pasta. We eat 1 bowl and we throw out the rest. That's how much waste there is from the most efficient of these meats, which is chicken. Oh, this is what I was talking about before, the European, but it's also in America now. We know that the best way to bring nitrogen pollution under control is to replace at least half the animal proteins with plant proteins. Land degradation, I'll just run through this quickly. 69% of the land is now degraded and 1/4 of the land is highly degraded. There's the map. It's pretty gruesome. Each year we lose 20,000 square kilometres to soil erosion, and 4 million square kilometres of cropland is now abandoned. Half the world's agricultural soils are gone, and some say that we have 60 years of farming left if soil degradation continues. So even if you disagree about the 60 years, there are some areas that are very, very deep soils where you're not experiencing erosion that will continue, but we need to do something dramatic about our soils. Principal causes of soil degradation: overgrazing, deforestation, and agricultural practices, mainly the way we crop our soil, plough our soil. So if you look at the crops that feed the animals and the overgrazing, the animal agriculture is the principal cause of soil degradation. Freshwater. This is another gruesome tale, but we get to the good part soon. By 2030, the world will need 40% more water, and 84% of cropland will have less less water with climate change. And the kicker for water is refugees. We've had over 20 million climate refugees per year for decades now. Most of them are within their own region, within their own country, but some of them get up and walk to another continent, as we saw with Iraq, Syria. This is the map of water stress by 2040. You can see that many regions in the world are going to be under stress. Water stress means less food. So this is a drastic thing that will come back to bite us. Sorry, I'm just repositioning here. Where does the water go? It takes 6 times more water to grow a kilogram of protein from animal sources, and it takes 20 times more water to grow calories from beef than from grain or potatoes. So that's where the water goes. You can see this graph from the FAO from some years ago. The potato takes 25 litres to grow, whereas a beef burger takes 2,400 litres to grow, and a glass of milk 200 litres to produce. So it's no secret, this is where the water goes. It's been well studied now, and the Stockholm International Water Institute has estimated that we will have enough water by 2050 if we reduce animal food consumption to 5% of total calories. That's equivalent to a 3/4 reduction of animal foods globally. That's equivalent to about a 95% reduction in animal foods in the heavy meat-eating countries. This is not academic. This is, will we have enough food to support the world in 2050? And water is going to be the limiting factor. Oceans. We've wiped out 90% of the big fish, the ones we eat, and bottom trawling has ploughed the continental shelves. We've destroyed those ecosystems. These ecosystems are necessary for the health of the oceans, which ultimately are necessary for our health. This is an incredible story of human folly, foolishness. I just find no words for this. There are fewer fish in the sea than ever before since we've been here, but the fishing fleet has gone up. Its capacity for fishing has gone up 10 times since the 1950s, and the catch has gone down. Even though we're really getting really good at catching more things, the catch has gone down by half. So we're shooting ourselves in the foot here. This is human folly on an amazing degree. I just can't get this. An example of this is the cod banks off North America. This was an incredibly productive fishery. Back in 1900, this fed the world in fish. In the UK now, it's illegal to buy cod for this very reason. If you look at the red zones here back in 1900 and compare that with 1950, 1975, and now 1999 was this study was done, those fish are now just about gone. The biomass of fish in the North Atlantic now has been decimated.